A project consists of 4 independent activities. The cost of activity A is exponentially distributed with a mean of $1,000. The cost of activity B has a 30% of costing $800, 50% chance of costing $1,200, and 20% chance of costing $1,600. The cost of activity C is normally distributed with a mean of $1,500 and a standard deviation of $200, while the cost of activity D is also normally distributed, but with a mean of $2,000 and a standard deviation of $500. Based on this and using a Monte Carlo simulation, please determine what is the probability that the project will cost more than $6,000, assuming all activities are statistically independent. What is the mean for the expected cost of the project, assuming all activities are statistically independent? And finally, what is the probability that the project will cost more than $6,000 if the correlation between activities C and D is 0.7? Now, to solve this problem, we need to generate 10 realizations of the project. So we do this activity by activity. So let's start with activity A. Now we said that the cost for activity A was exponentially distributed. So the cost for A, our exponential formula was minus lambda times the logarithm of our U value. So lambda is our mean, so this is equal to minus $1,000 times the logarithm. Well, we need to look up our table, and what we can see is the first number on the table is 94737, so we put in 0.94737. So this gives us $54.07. So let's put this down here to keep track of it. So we've got $54.07. Now, for activity B, we were given a lookup table. And so what it said was, for $800, the probability was 0.3. For $1,200, the probability was 0.5. And for $1,600, the probability is 0.2. So to create a lookup table out of this, we'll say 0 to 0.3 gives us 800, 0.3 plus 0.5, so to 0.8 gives us 1,200, and then 0.8 plus 0.2 gives us 1, to 1.0 gives us 1,600. Once again, we look at our table to work out what the next number on the table is, and the next number on the table is 87259. So we put a 0 point in front of that. Now this can be found in this range. So therefore our answer that we're going to use for this one is $1,600. Now, we said that activities C and D are both normally distributed. So to solve these ones, we'll need to use the Box-Muller method. So we're going to calculate Z1, which is equal to the square root of minus 2 times ln of U1, and the square root goes all around that, times the cos of 2 pi, and remember if your calculator is in degrees, that needs to be 360 times U2. And Z2, as before, equals the square root of minus 2 ln of U1 but this time we'll multiply it by the sine of 2 pi times u2. So we need to know what u1 and u2 are. Once again, we'll look up our graph and we'll find out that u1 is going to be 0.63856 and u2, we're going to use the fourth number in the table, which is 0.6612. So Z1 is equal to the square root of minus 2 ln 0.63856 times cos of 2 pi times 0.66612. Once again, the first part is going to be the same, minus 2 ln 0.63856, but this time it's going to be sine of 2 pi times 0.66612, which is equal to minus 0.47639, and the second one is equal to minus 0.81862. So using Z1 and Z2, what we're going to say is activity C the cost is equal to, well, the mean cost for activity C was $1,500 and the standard deviation was $200 times U1, which is minus 0.47639, which gives us 1,404.72, whereas for activity D, the cost is equal to, we have a different mean this time, so it's going to be $2,000 plus, and we have a different standard deviation, 500 times, and this time we use Z2 instead of Z1, 0.81862, which gives us $1,590.69. So we copy them down here and we've got $1,404.72. And for D, we have $1,590.69. So now we have the cost for activity A, the cost for activity B, the cost for activity C, and the cost for activity D. So we want to have the total cost for the whole project, so we simply just add these four numbers together and we get $4,649.48. So this gives us the table for our first realisation. Now we need to do that again another 9 times. And here are the answers. The first question is, what was the probability that the project will cost more than $6,000? We can see that this occurs in realisations 2, 5, 6 and 9. So 4 realisations out of 10, which means that our probability is 40%. The second question was, what was the mean for the cost of the project? In this case, all we have to do is determine the mean for these 10 total costs, which gives us $5,806.97. Okay, solving the problem when we have independence is fairly straightforward. The more difficult part is how to solve it if we start to say some of our activities are correlated. So we said that the cost for activity C and the cost for activity D are going to have a correlation of 0.7, which means that we need to recalculate all of the costs for activity C and recalculate all of the costs for activity D. Now, how do we do this and how is it different? Well, to start off with, we need to know the covariance matrix between these two activities. So, a covariance matrix is a matrix that has as its diagonals the variance for each different activity. We said the standard deviation for activity C was $200, so the variance must be that squared, which gives us $40,000. Then for activity D, we said the standard deviation was $500, so therefore the variance must be $250,000. Now what about the other two numbers? What's the covariance between C and D? To do this, we multiply the standard deviation of activity C by the standard deviation of activity D, and then multiply that by their correlation. So 200 times 500 gives us 100,000, times 0.7 gives us 70,000. And this is a symmetric matrix, so we get the same answer in both corners. Now we need to work out the Cholesky decomposition of this. I'm going to cheat. I worked out the answers using an internet page that does these calculations for us. And we get 200, 350, 0, and 357.0714. So this is the Cholesky decomposition of the covariance matrix. Now, to work out the cost for activity C and activity D, we need to multiply the vector of Z1, Z2 times this matrix and add that to the vector of the mean values. So, for the activity C, the cost for activity C is equal to, well, first of all, the mean value has stayed the same, and the mean value was $1,500. Now, when we multiply the vector, what we're essentially doing is multiplying this vector by this vector to get the part that goes into C. So it's going to be 200 times minus 0.47639 plus 0 times minus 0.81862. And this gives us $1,404.72. Now you might be looking at this answer and saying that's the same as we got last time. That's okay. It only works for the first one because the first line in this matrix will always have a number here, which will be the square root. In other words, the standard deviation, because it'll be the square root of the variance over here, and there'll be 0 everywhere else here. However, all of the other multiplications will be different, so we'll get a different value for cost D. So cost D is going to be equal to, well, the mean for D was $2,000 plus instead of using 500 like we did last time, we take our numbers from here, so we use 350 times Z1 minus 0.47639 plus we use this value here, which is 357.0714 times minus 0.81862, which gives us $1,540.96. Right, so what you'll notice in this case is because cost C ended up being below the average, cost D had a greater chance of being below the average because of the correlation. Most of the time, putting in most numbers, you'll get these two will be either both above or both below the average, but sometimes it'll be the opposite. Once again, we add up cost A plus cost B plus cost C plus cost D, and this time we get $4,599.75. Once again, we can take a spreadsheet. We've worked out the first row. Now we can add the other 9 rows, and we can see that in general, D is more likely to be high when C is high and vice versa. So getting back to our questions, the probability that the project will cost more than $6,000, we count how many times the total is greater than 6,000. We can see that as before, this turns out to happen in realisation 2, 5, 6 and 9, so the probability is still 40%. Now, to calculate the average, we determine the average of these 10 total values over here, and we end up with $5,835.67, which is not very different from our previous answer.